Okay, I guess people are worried about the midterm is coming in really soon. So a few things I should mention. Number one, this Friday, because this is your first midterm in the course, and then we just started, and everybody is settling down here and there. So just let you know, I'll try to be very gentle. Okay, I will be gentle in terms of the question, in terms of the amount of question, as well as the challenge level of the question. The second thing regarding the sample midterm, I do have some sample that's actually already included in the curriculum. It's about 10 questions. If I see there is an appropriate sample question, I will provide more. But for the first midterm, I don't want to mislead anybody by providing a lot of stuff. So that's for the first midterm. I actually will have some sample question in this lecture. I just remember that. Okay, the third thing is that everything I'm going to ask this particular Friday will be included, everything I already talked about, as well as this particular lecture. Meaning that if there's any new things I actually talk about on Wednesday, it will not be included in the midterm. Okay, so today is kind of critical, so you actually can see that what was actually there. Okay, the other thing I want to mention, this is also a bit of logistics or administration. If you look at the file, we're looking at this particular repository on GitHub, CPP01 person and thing. You see that I actually change it. I actually modify. And the thing is that what did I modify? Let me actually show you what did I modify. I didn't actually modify the code. Or I just did a little bit of modification like what I did at the end of Friday to kind of move a statement from the private to the public. But the things I modify is about the curriculum or concept associated with the code. For example, you see that I'm actually adding this portion. If you remember that this is what we actually talk about, private and public. So not only we cover the topic and we use this code, and I try to do my best, try to provide some annotation with the code, which help you to link what we're talking about. And then, so when you look at the code, you actually can actually see what is the concept when we actually talk about the code. Okay, that is the instructor. For example, earlier I talked about, I think this was last week, I talked about, when I talk about this piece of code, I talk about the syntax, the overall structure. Well, then let me make it a little bit bigger. Okay, and then I talk about, remember, this is what we talk about. Yeah, you try to move one of the line from private to the public. So essentially, over here, we're trying to see what's the difference between private and the public. That is an important concept. I might ask you this Friday, what's the difference between private and the public? And then I provide some example that you can actually play around. And then this is actually, I'm going to talk about the rest of the function. Oh, sorry, private, public. And then I actually going to talk about this 6 function, GPSDD, another GPSDD, and then the get latitude, get longitude, distance, and dump. And then you actually see that I start to provide some explanation. So I will keep enhancing this code with explanation as we actually went through the concept. And sometimes I make the modification just because some of the students ask some question, either online or office hour or in the class, and then I feel it's valuable. So essentially, this set of code, this set of file is not just for you to see it as a piece of program, but more importantly, it's actually integrated with a bunch of concepts that you're supposed to learn when you actually go through that. Okay, and then you can actually just hopefully you can make a copy and add more to yourself. So because as you learn, you actually learn something new here and there, and then you can actually modify that yourself. Okay, so so that's just let you know this is logistics. You can you should take a look at that. Okay, so last time, let me actually go back to my code. Sorry, I still decide to use the white background instead of the green or black. It's kind of last time I realized with the Emacs, it's actually confused the screen because sometimes we'll have a purple and things like that. Let me actually just move here. Okay. No, this is my break. Here. Okay, so let me review what we did last time. So we talked about the difference between private and the public. So if you now take a look at this piece of code, I also make some modification, not the code, but also adding the explanation about the explanation about what we are doing. So this is a line of code that we add. So let's actually try to parse this line of code. Let me make it still bigger. Is this size appropriate for the last row? Good, okay, thank you, appreciate that. So we'll talk about this line. Let's actually take a look what this line is doing. So this line is essentially printing a floating point, printing the floating point, and the value we try to print, the most important part is this one, GPS home woodland dot latitude. Okay, so I want to actually parse this a little bit. So when I parse this particular part, I want to say that GPS home woodland is a GPS DD object. Okay, it is a GPSD. So obviously, a implied question I'm asking you is that what is the difference between class and object? Okay, so we can see that when we look at GPS.h, that is a class definition. And then when we instantiate from that template in the GPS.h is this line, we say class name, GPS home woodland. Just like you say int I, you declare an object I, which is the class or type is integer. Okay, that's the general format for most of the object-oriented language, including Python, including C++, including Java. So when I say most, I do want to say that there are object-oriented programming language which only has a concept of object, and they don't have the concept called class. There are some programming languages do that, but I don't think they're very popular in modern day. Maybe 30 years ago, there are some language you can do that. For example, Smalltalk programming language looks like that. Okay, so all right, so now you know that this is the object. So when I say object dot, then latitude, you see that. What is a latitude? Latitude is a member in the class GPS, which is declared also in GPS.h. So essentially, it's object dot a member. That means you can actually, through the syntax, to access the internal of that object. So the object is called GPS home woodland. And then inside there, internally, there is two attributes. One is latitude, one is the longitude. So essentially, by doing the syntax, that you can actually do that, right? So if you remember correctly, if you still remember, this code will generate what we call compiler error. So if I do make, you see that there is a compiler error when I try to compile the test thing person.cpp, and you can see that the arrow is pointing exactly at this, saying that what? So that's important for you to read the compiler message. That's a textbook as well. It says latitude is a private member of GPSDD. Because it's private, so now you see that the concept of public and private is really try to protect your internal attribute to see that whether that internal attribute will be able to access directly from outside. Instead, if you remember the GPSDD definition, is actually putting both latitude, longitude in the private, and they do have a function, what we call member function, which we will cover that today, called get latitude and get longitude. So essentially, I have a two function. If you want to access the value, then you should use this two. Okay, so now I'm going to ask you a bit of tricky question, okay, a bit of tricky question. If I actually do this, like what I did on Friday, it's a latitude, right? If I do move this line and move here, if I do this, okay? So you can see that it's a very simple change. I'm moving one line from private to the public. And if I compile, now the code should have no problem because now I already move it to the public. What's the disadvantage of that change I just made? Yes. Exactly. That variable, not only I can reassess, right? Get latitude is a reassess, but because I make it public, you can modify as well. So essentially, that's very dangerous. So the concept is that I want to write a piece of code which will guarantee the integrity of my GPS location. Once it got created, you shouldn't change or whatever. I mean, assuming that we don't want people to change randomly. So make it public to private, and the compiler can actually check whether you access the variable appropriately. So that's the job of compiler. The programming language design is trying to design such that the programmer is allowed to do whatever they want to do, but to also make sure that the programmer, meaning that I'm actually using somebody else's code, I'm using somebody design an object called GPSDD, and I want to make sure that whatever they did is actually protect the data is using the right way. Yes, please.
Can you do that in code? Private, you can't modify if you're compiling it or using it kind of thing. And within the code, you still
yeah. You actually asked a very important question, but it's a very challenging question. Let me actually tell you what you just asked me. There are different levels of text. I'll go over. Okay, so whatever I'm going to talk right now, it will not show up in your midterm, probably for the whole quarter, because I think is actually pretty deep, except that one. I'm not just kidding. You're going to ask me a question. So, okay, number one, the compiler can actually protect, right? But the thing is that a lot of today, the C++ code it was pre-compiled with the .h file, which is like GPS.h file, and then got released. Okay, so which means that when they compile their library code, they actually protect it. But when I actually try to compile, I actually modify the .h file. Like what you said, I move it from one place to the other, and I compile my code. I'm still doing whatever dangerous things I would like to do. Okay, that's number one. An even more dangerous situation. That's why I don't want to. Let me just show you an example. Okay. Let me actually tell you what kind of hack that C or C+ programmer can do. Okay, so for example, over here we're actually let me get rid of this first. Let me actually make this, copy it back first. So this is I will call it a gray area of programming, especially in the C and C++. Okay, if you take a look at this, if I don't want to do this, I can do write code looks like this. I can actually have a pointer. I call a void star pointer. I call the generic PTR. Okay, it's a pointer. And then what I did is I cast it with a void star and GPS home. Okay, so essentially I actually casting that pointer to an address, to a generic pointer. Let me get rid of this. And then what I did is, assuming I have a way to figure out an offset. So later you will talk about memory layout. So why does C++ programmer need to be aware of memory layout? Because you know where in the memory for each of the attribute, including those function pointer, it was located. And that was a public knowledge that you should be able to do that. So assuming I can figure out the offset of that variable attribute, then what I did is GPTR is equal to GPTR plus the offset for latitude. Okay, to figure out the offset is about over 4 or over 5. Okay, so I actually figure out the offset. So I added to that. So essentially, I moved the pointer over there to where I pointing to the latitude, and then I can just say, print latitude, but over here, I will just say star float star GPTR. Okay, I just do the 3 line. I basically bypass compiler because essentially there's no way for compiler to check. I try to directly access to that. So which means that I can actually directly modify the value. For example, I can say star is equal to 20.0, for example. I can actually do that. There's no way the compiler will be able to pick up saying that, hey, you tried to access a private attribute, because I already use all this casting to evade from the detection of compiler. So then this is the reason I don't want to ask you any question related to this in the exam, is that this is certainly a hack. I will not say in real software development, sometimes I need to do this. There are cases I have to do this. But the thing is that most commonly application development, not system development, or not, you're not doing any kind of cybersecurity hacking, then essentially this is the capability you shouldn't do it. So in other words, I said, hey, if you're an advanced programmer, you should all learn, you should know all those potential tricks that you can do with a language like C. Okay, this is, by the way, this is impossible. You cannot do this with Java or Python. This is actually very unique to C and C++. Okay. Does that answer your question more or less, or maybe more than what you asked? Yeah, okay. All right, so any other question regarding what we have covered? Yes, please.
Sorry, just out of curiosity. So basically, those three lines of code are doing what a setter would usually do, correct?
Say that again?
Those three lines of code are doing what a setter would usually do. So it's like a hack moving this setter.
Yeah, if I want to hack into this, if I want to say, so it's really dangerous actually. In some sense, C++ is a dangerous programming language because it gives you the capability, even if you say this is private, I can use this kind of trick to actually modify anyway. And the compiler won't be able to. So the compiler is checking a more of the basic usage of the language. Yes, please.
If you're not better, and if you're not better, then like what's the point of making that input? It must be like this, like in general, like I know some people have like getters and setters and then
Right. I would say that it's just a language. I feel that C++, they have a good intention. It's like they say you shouldn't do it this way. You shouldn't try to do that, but if you can you do that? Yes, you can. In C++, in C, because of the C, because of the pointer, because of the address. That's the that make it hard. But this is perfectly reasonable for any other programming language like Java. Because when it says it's a private, it really enforces as a private versus public, regardless how you do that. Because they don't have the address. And that unique capability. So I'll just be honest with you, whenever I talk about programming language with C and C++, I always has a mixed feeling. It's a language I can do whatever I want to do, but it's a language is really imply a lot of risk. Okay, I saw another hand. Yeah, you first, and then go ahead. Okay, I will talk about offset latitude is essentially saying that what is the address difference between the beginning of the object and the beginning of the attribute called latitude. Yeah, we will have homework assignment actually to figure out how to calculate that. Good questions back there? Yeah.
Yeah, that was the same question.
Okay, all right, good. I'll because if I try to explain how do I get it, it's just too much stuff. Okay, that kind of deny me finish what I really want to finish for today. Okay, so all right, good. All right, all good questions. Great. Okay, if you have any more questions, please bring up to online or bring it to office hour as well. Okay, thank you. So I want to ask you the following question. This question I feel is more important, but it's related to what we just discussed. So when we have that particular line, let me actually try to get it back. I will upload this few lines of code at the end of the class, this few lines. So if I do this, and I'm going to get an arrow. And if you pay attention to what I said, this arrow is called compiler arrow because it was generated when I run the compiler. So the compiler GCC or G++, they actually pick up this arrow. Okay. And so my question I want to ask you, you might already learn this from your previous class, but I want to just double check. I put it here. I put it here in this line. This line here. What is the difference between compiler error and runtime error? So how many of you have heard about the term runtime error? Okay, maybe 1/4 of us actually. Thank you for your response. I mean, about 1/4 of us. So for those of you who actually know, can someone tell me what's the difference between a runtime error and a compiler error? Yes, please. Yeah. Okay, good, thank you. So essentially, compiler error is when we try to build the executable, like when we type a make, right? Eventually, it's actually generate the code. If you know what the compiler is doing. Thank you, by the way. So if I do this is I cleaned it already. So everything is a source code in this directory. And if I do a make, you can see that it's actually the last line is actually link all the .o file, the object file, and then generate an executable called test thing person. Okay, and then this code is actually runnable to generate this code. So essentially, the difference between compiler and runtime error is that in the process, any error that's actually being caught until we generate that executable testing person. Any error in this stage is called compiler error. And then after you're done with the compiler, when you try to run the program, you can see that I'm actually trying to execute the program. When I execute the program, any of the error that's actually being caught at that time is actually what we call runtime error. Okay, that's just let you know any question. By the way, this concept is very important in software development. You will see more, especially when we actually talk about exceptional handling. Exceptional handling is a capability that provided by modern programming language such as C++ is trying to deal with the runtime error. Okay. Any question? Okay, good. All right, let's actually move on with the code. Now I can finally get to the GPSDD. Okay, now we're going to look at the function. So last time, some of you asking, we have a 6 function. Okay, so my objective by the end of today is try to finish the introduction to all the 6 functions. The first thing I should say is that there are, how do I, let me actually first say this. You see that there's 2 functions is the same name as the class name. Okay, I have a 2 GPSDD. So just want to tell you that this 2 function has a special term we specify is actually called constructor. So constructor is like initialization. When you actually create an object that essentially the operating system gives you a bunch of memory that you can host that object. But then you need to initialize the value. You want to put some value and such that, for example, initialize that into some value for your latitude and longitude. So that's why you have two, in this case, you have two constructor function. But you can see that this function signature of the constructor is different. The first one doesn't take any argument. The second one takes two arguments. So just for Python programmer, that this is in Python, this is what we call init. Okay, so those of you who have done Python programming, in Python, if you want to create an object, and then you want to actually initialize, is actually underscore, underscore, init, underscore, underscore. That's actually Python. And in Python, usually the init has a, the first argument is for self. Self means that is a reference to the object itself. And in C++, we actually have a similar one. It's called this. Okay, so if you're a Python programmer, if you look init and self, then you know the constructor and the this, they're basically equivalent concept. Okay. All right, so those two are constructors. So now let's actually take a look at the code. So the code is actually under GPS.cpp. Okay, so one is the declaration about the class, and one is really provide the implementation. So you can see that, let me actually just go here. So in this code, GPS.cpp, the first line, of course, I include the file for the definition, which is gps.h. And you can see that this few lines of code is the constructor. See that? The first one is the constructor, which is GPSDD, and then without any argument. So inside here, you see what I did is I said this, just like a self. If you're familiar with the concept from the Python, this to the latitude is 0, this to the longitude is 0, meaning that if you don't set it, I'm actually going to set it to be 0. Okay, that's just zero initialization. But then I can do this as well. I can do another one, which is another constructor, which has latitude and longitude, two arguments, and then I just set the latitude to be arc, latitude, and then longitude to be arc, longitude. Okay, so that's the implementation. Okay, I will explain a little bit later about what does this means. GPS DD, colon, GPS DD. You see that in the GPS.h, I only say GPS underscore DD, but over here, I actually almost everything in the green, you can see that GPS DD, colon, get latitude. I will explain that notation a bit later, why we have to do that. Okay, but this is the constructor. Any question? Okay, now let's actually take a look at how the constructor is being called. So the thing is that you have a constructor, but then how do I invoke the constructor? So let's actually go to the test program because that's where we create the object. So if you come over here, that this is where I create the object, right? The object is GPS home woodland. And the class is GPSDD. So we create the object called that. So when I create the object, I should actually call the constructor because I want to make sure that the object is actually being done correctly. So just let you know that this notation is called bracket initialization. Let me put a bracket. Okay, this become probably the most commonly used way for people to initialize a C++ object. By the way, bracket initialization was introduced later in the history of C++. When I first learned C++, by the way, I first learned C++ in 1987, where the C++ was introduced in 1986. At that time, a lot of the feature such as bracket initialization, they're not there. Okay, so just let you know, but this is about C++ maybe plus C++ 11, C++ 17, C++ 14, they all have this. They become really popular. So essentially, bracket initialization, you provide two arguments. And they actually, the compiler match this two arguments to the second constructor that you have here. So essentially, when I do that notation, I'm actually calling this particular one. So essentially 38, whatever this number is going to be automatically assigned to arc latitude, and where the second argument minus 121 is actually going to the second argument. Okay, so this is actually a match from that over here. I just want to show you alternatively, this is what you can do as well. Yeah, by the way, I haven't done this for a long time, so I hope the compiler won't complain. So I'm actually going to do this. Wait a minute, how do I do this? Like this? I forgot. Let me try it. So I haven't done this for a long time. This is another notation. Yeah, it works as well. You see that this is another way to do it. This is not a bracket initialization. Oh, sorry. I'm not looking at this file. You can see this is the older style. The older style is essentially when I create the object, I'm actually directly call the constructor. And therefore, I'm actually having this function call syntax. You see that is a parenthesis with two arguments. So this two lines, they're actually syntactically the same. But the thing is that sometimes people look at this, they kind of a bit confused, saying that, well, you're actually trying to call a function, it's an object, you actually have an object to call that. It's sometimes, I mean, arguably, that people feel that this is a bit confusing. So that's why most people today using this bracket initialization, okay? But they are the same. I'm going to leave both versions there to just for you to understand the history about C++. Okay, any question about this? All right, good. All right, so we're done with the, let me see how many minutes. I have 8 minutes. That's really great. So now I finally can look at the other function. Okay, so now we took care of the constructor. And now I'm actually going to take care of the other four function, which is we call a member function. So in C++, I have two terms I like to use. You can actually mix them, but that's okay. One is called member, one is called member function. So usually I will call an attribute like a longitude and latitude, I call it is a member attribute. But then in a function, like a GPSPD or whatever function design, I call a member function. Okay, technically, I think that's the term I should call it. So I have a six member function, but two of them are constructor. The rest of them are get latitude, get longitude, distance, and done. Okay, so there are two issues I need to address within the next 8 minutes. So meaning that, okay, how do I actually provide the implementation of the function? And also, how do I actually identify this function? How do I actually identify that? So first, I want to talk about the identification, meaning that how would I be able to represent the function signature about the member function? So let's first go a little bit about the definition. So what is a member function? What is a member function? So just to clarify that. So member function is a function associated with a class and not associated with an option. This might sound very obvious to you, But I think it's important, I want to clarify that. So meaning that all the objects within the same class, they share the same function implementation. Okay, that's a member function. So member function, number one, is associated with a particular class, not associated with the object. I want to clarify that. Therefore, when I try to provide the identifier for the member function, I need to identify two things. The first thing is the class name. And the second thing is the member function name. So, for example, in this case, get latitude is a function name, but that's not enough. I need to have the class name as well, because I could have another class have the same function name. So in order for you to uniquely identify a function in the C++, you have to provide both the class name and then separate by colon, and then associate with the member function name itself. Okay, so such that, for example, if this function is called GPSDD, I'm sorry, I make a mistake here. If the function is called GPSDD as a constructor, then you should have GPSDD. If the function is get latitude, it should be GPSDD and get latitude. That is how you identify. So over here, I didn't actually write GPSDD colon before that because it's already included in the class GPSDD. So that's why within the class, I don't have to say that because I already declared this. But it's actually going to be different if you go to GPS CPP. You can see that everything here is outside of that GPS.h. I try to separate the implementation from the declaration. So you can see that every single function has that class name. So just want to let you know the green part represents the class name. The blue part represents the function name. Okay, so this is this. So let's take a look at the third function, which is get latitude. So now you can see that the class name is GPSDD and the function name is get latitude. And how do I implement? Just return that. Okay. So I have a couple minutes. I want to tell you that what is the next function. That's actually pretty big function. This function is called distance. So what distance is actually trying to calculate the distance between two GPS locations. I mean, for example, I want to calculate if you want to fly from Sacramento Airport to the New York JFK, the Kennedy Airport, what is the distance between these two airports? Then essentially you need to enter two GPS locations to figure out what's the distance. So in the design of the GPS class, what we did is that we actually take a look to say, okay, the distance is actually you gave me a GPS, another object, GPS another, and then I can actually calculate what's the different distance within here. So you can see that I actually call a function called geo data source distance, which is defined a little bit up. I just passed that code. And you can see that I'm actually giving two GPS location. The first GPS location is my own GPS location. That's this latitude and this longitude. And then the other one is another, which is, say this is actually Sacramento Airport. And another is New York Airport, John Kennedy Airport. And then another dot get latitude, another dot get longitude is actually providing me the coordinate of another GPS object. So by enter this 4, and then with the other M, just to let you know, the M, if you look at the code, the M represent miles. You want to calculate the distance by miles, or you want to calculate distance by kilometer, that's your choice. So M is a miles, and this function will actually get you exactly the distance, and the code is above there. Okay, so the last part, I want to actually tell you, in fact, if you learn everything I provide you today, you kind of already have a basic capability to actually implement any C++ class. But the last example is the hardest. Why is that? Because the last example is actually not talk about one object, it's talk about two objects. That's actually very difficult. I mean, some of you might have done this similar thing before, but when you have an object, everything I just worry about how do I calculate what value. But when you talk about two objects, maybe there are a relationship between two persons or a relationship between two GPS locations. And conceptually, from the programming, it might look a little bit complicated. Okay, in this case, that I need to actually include one object as an argument, send it into another object. This sometimes looks actually kind of hard to read, but we will actually cover that. Okay, later in the class to tell you what other option you have. Okay, I'm going to stop here and see you on Wednesday, or some of you on Tuesday, tomorrow, office hours. 1 second.